Introducing X2D. Hey, I'm Max. This is Bambu Lab's newest printer called X2D, and for some reason I've got 1, 2, and 3 of them.
So when I just got the machine, I was like, it looks exactly like the X1 Carbon. Is there even a difference? Why even bother making a second one, right? Well, boy, was I wrong. After making these 2 little projects using X2D, I think there are 2 things that interest me. The first one is this lightweight, high-speed dual-nozzle tool head. The second being this actively heated chamber, which the X1 doesn't have. But of course, there are more bits and pieces which are not exactly new, but more similar to stuff on the H2 series, like this filtration system, calibration plate, 1.5 GT belt, and also this inbuilt pressure advance calibration thingy. By the way, the price is only
$649 USD for the printer and $899 for the AMS2 Pro combo.
My review might seem a bit different from others because I do not print benches or calibration cubes. I make projects. Hopefully, after watching this video, I can show you what this machine actually brings to the table when making a project. The first model I made with X2D was this little mecha thingy. It's a little promo piece I made for Bambu Lab, but at the same time, I want to challenge myself as well as challenge X2D, right? I like to make big stuff, like this, all these 2 in the background. I know most of my projects, they are kind of big, I know, but the main reason behind that is it's just so difficult to make them small when using FDM technology.
Like this, one of my smallest models, this mecha girl thing, is 40 centimeters tall, around 50 inches. To make a figure small, it's almost never about details being too small to print or other superficial stuff. The one thing that actually matters about the size is the joint. At the time when designing her, I did not have an H2D because it was expensive. By the restrictions of hardware and software, the only way to make it was to print the TPU part and the PLA part separately. But then comes the problem. To make a joint strong, to make it able to hold more weight, I need a larger surface area of TPU. Then it leads to more PLA, then it gets even heavier. Then I need even more TPU than PLA, well, you get the point. So at the time, I had to make it 40 centimeters tall as a compromise, just to be able to use an FDM machine to print. Luckily, we have a solution now. Just like on the H2D, on the X2D we can have interlocking materials, which by themselves do not stick well, like PLA and TPU. To explain this whole interlocking thingy, I will just use the mech's pelvis part as an example, since it was one of the first parts that I've designed. In an ideal scenario, we would like the TPU layer to be thin, but the PLA skeleton to be a lot thicker and stronger for a robust joint. And we use the outer TPU layer to provide resistance and friction against the other half of the joint.
Well, in order to do that, we have to do a few things. First is to print this kind of TPU without moisture.
We can use the AMS HT as a filament dryer, or just use a dedicated one. Then we can route the TPU into the TPU sys module. Then we can print TPU with the main hot end, with the printer's lid closed. Then, since TPU cannot be pulled back into the AMS, we need to put those hard materials like PLA to another AMS and connect to the auxiliary nozzle to achieve a TPU plus PLA print. But at this point, just like the silicone sleeve on a pen, the printed TPU and PLA, they will just slide and twist against each other with any kind of force applied, since they don't really like to stick that well, right? To deal with that, we can tick the checkbox for beam interlocking in Bambu Studio. It locks those non-sticking materials layer by layer like a zipper, so the TPU shell is held in place permanently to the PLA. As shown in the video right now, even if the inner PLA core is broken, the TPU is still stuck on it. And of course, since we are already using TPU against PLA, we can utilize that and use them as support material for each other. And since TPU is soft, the support is actually easier to remove.
Before we get to other parts of the X2D, there is one last thing I think I want to talk about this dual nozzle hot end. Is there even a difference between the X2Ds and H2Ds tool heads? Well, after playing with it for like a month, I guess there's no better way to explain this other than showing this picture.
On the H2D, the motorized switching of nozzles made the tool head so heavy that using a high flow nozzle does not really provide any kind of significant increase in printing speed. While on the X2D, by eliminating the motor-driven nozzle actuation and by using pure mechanical means, with the help of the high flow nozzles, it becomes one of the fastest Bambu machines you can buy. Also looking at the printing area, by removing direct extrusion and putting a Bowden-style extruder at the back for the auxiliary hot end, the main nozzle gained the whole place printing area, which is 256 by 256 by 260, and that I believe is how the left hot end, which is a carbon copy of the H2's direct drive, is called the main hot end, while the right one using the Bowden is called the auxiliary hot end. But don't panic over the Bowden style. It's 2026. Bambu Lab has figured it out. Other than a little reduced speed for the auxiliary nozzle, with the help of the 1.5 GT belts, you can see my little robot's multicolor PLA parts all printed nicely with Bambu Lab's default values.
Well, if I have to nitpick on the tool head, there may be like two things I don't really like. The first one being on the auxiliary nozzle, the Bowden style pressure advance can only be done manually. So if you're using Bambu Lab's filament, it's fine, I guess. But if you're using any kind of third-party filaments, then you have to do it manually. Well, the second one being that if you have to print anything flexible, like TPU or PBA, then it can only be done on the main nozzle, which if your project is kind of complicated, then it's complicated.
While talking about pressure advance, it makes printing TPU a breeze. And it's kind of like a perfect segue leading to the second part of the video, where I'm gonna talk about this little mecha head. This mecha head here is a little project I did with the help of my friends for TCT Asia and for future conventions, I guess. I'm still currently working on detailing the mech, and for the structural parts I used this dark nickel colored ABS, since I was told that it has actual aluminum powder in it, so the default ABS values in Bambu Studio is not gonna work. Luckily, X2D's pressure advance did its magic. All the corners which is supposed to be sharp is sharp, the round ones round, and the seams they all line up. Oh, I almost forgot. The largest upgrade for me is actually the active chamber heating in a 256 Bambu machine. I wanted so bad when testing the P2S, but we finally got it, right? For me, I just don't print PLA or PETG that often. This is perfect. And also when using a 0.6 hardened nozzle, I can crank up the temperature to the max, like 300C. And with that, I can print the gears in PPA-CF with the 65C chamber temperature, which comparing to the ABS parts, PPA-CF should be a lot stronger. Also by using the filament called support for ABS as the support material, just like PLA with TPU. The part can be printed nicely with zero support gap. This not only leads to an easier support removal, but more importantly, the dimensional accuracy in the Z-axis is much tighter comparing to the normal support. On the neck part, where a bearing needs to have a tight fit between the top and bottom part, the zero support Z distance really helped.
To give a little conclusion, I have been using this machine for like over a month and making those two little projects. I consider it to be a productivity tool, if you understand what I mean. And my review is purely based on my experience of like actually developing those projects. And right now, when I'm reviewing the script, I realized that I have somehow ignored some of the features this machine actually provides, such as the precision board, the belts, and the noise control on this. But right now, I kind of understand why I ignored them in the first place. Because for me, it's just a tool. I would not recommend this as a Christmas gift for a first-timer. Also, I wouldn't recommend this for a tinkerer to tinker with. And I don't even think this represents Bambu Lab's newest tech in the 2026. It's just a tool, but as a tool, it's a great one. If you need to print stuff mostly under 256 cubed, and also want to try the dual nozzle setup because you want to eliminate the supporting artifacts, or if you want to print more than PLA or PETG, and want into the realm of stuff like ABS, nylon, or PPA or even PPS, and you don't want to pay the price of H2, then this is a great choice. But at the same time, if you have doubts or you don't really understood what I just said in the past 5 minutes, then maybe you want to look into the A1 series or the H2 series. Alright, that's my little review of the X2D. I am Max, and hope you have a good one.